Hi everyone, welcome back to my YouTube channel. Today we are going to look at refraction, refraction of light. Now, if you place a pin into a bowl filled with water and you look vertically downwards to see the pin, you're going to observe that the pin is as if it's lying on top or on the surface of the water rather than being in the bottom. Then why is that effect so? It's because of what? Refraction. When light move from one medium to another, because they have different densities, it tends to bend at the boundary between that two media, and that is what that causes the word refraction. So let us look at what is refraction. Please, if you are watching this channel for the first time, I want you to give it a thumbs up, subscribe for more videos. Refraction is the bending of a light ray as it crosses the boundary between two media of different densities, thereby causing a change in each direction. Like I said, when light move from one medium to another, because one medium is always obviously denser than the other one, so as it crosses that boundary there will be a change at that boundary. So let's look at this diagram on the board. This is a light ray. This is medium 1. Let me assume that this medium 1 is air, while this medium 2 is what? Glass. It can be glass or water. So when light ray crosses this boundary from medium 1 to medium what? 2, there will be a bend, because this glass or water, they are all denser than what? Air. So when this light ray move from this medium to another medium, at this boundary there is what to call what? A bend, and that bend is gives rise to what to call refraction. Now this is my normal, this is normal. This normal is a line, a vertical line that is perpendicular to the reflecting what? Or to the boundary between these two what? Media. This is the angle of the incident ray. The angle between the normal and the incident ray is said to be the angle of incidence, and the angle between the normal in the medium and the reflected ray is said to be the angle of what? Reflection. It's said to be the angle of what? Refraction. Sorry, angle of refraction. So there is a law that governs this refraction. We call it the law of what? Refraction. So let's look at it. It has two laws, the first and the second. The first one says that what? The incident ray, the refracted ray, and the normal at the point of incidence all lie on the same plane. So let me explain this law with this diagram. It says that the incident ray, the refracted ray, and the normal is not a ray, it's just a line. At the point of incidence, this point, all lie on the same plane. Let me go again. The incident ray, the refracted ray, and the normal at the point of incidence all lie on the same what? Plane. That is the first law. The second law says that what? The ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for a given pair of media. Look at the angle of incidence, look at the angle of refraction. So there is a ratio between them. The ratio of the angle of incidence I to the angle of refraction R is a constant for a given pair of what? Media. And this constant is what that gives rise to refractive what? Index. It gives rise to refractive index. So I'm going to show you the relationship between the law of refraction and the refractive index. Of course, we are going to use such relationship to solve problems. Stay tuned. Okay, so let's look at a rectangular glass block and explain the concept of refraction. Now, this is a rectangular glass block A, B, C, D. This is a normal. A normal is a line perpendicular to this surface. Okay, that means if it's perpendicular, it means it is at right angle, that is 90 degrees. Now this is incident ray. I call it incident ray. A ray of light that is moving towards the refractive glass block is said to be incident, so it is incident ray. Now look at this angle between the incident ray and the normal. We call it angle of what? Incident. That is our eye. Once this light pass through this medium is air before the glass, and this is what? Glass. So because glass is denser than air, what do I mean by denser? It is heavier than what? Air. Because it is heavier than air, we are going to find out that what? Once it reaches this boundary, it's going to bend. You see how the ray has bent inside the glass block? That is where we have the angle of what? Refraction. And the angle of refraction is the angle between the refracted ray, which is this, and the normal. Okay, so if you try to extend this incident ray vertically through the glass, we are going to see the way in which it has deviated. So this becomes my angle of what? Deviation, right? Now if I come down to this way, because I have gotten to this point, and this is equally another normal which was gotten from a right angle what? Triangle, making this one to be what? 90. The angle of emergence becomes the angle between the emergent ray and the normal. So there is a relationship between this and what we stated as our Snell's law. That's laws of refraction. Number 2 can be said to be Snell's law, and it states that what? The ratio of the sine of the angle of incidence to the sine of the angle of refraction is a constant for a given pair of media. So what do I mean by that? If I say A and what? G, what does it mean? When light travels from air to what? Glass. From air to glass is equals to sine of angle of incidence, that is sine of this angle of incidence I, over sine of angle of refraction R, over sine of angle of what? Refraction R. That is the relationship. We can also say that it is also equals to velocity in medium 1 divided by what? Velocity in medium 2. We can also say that it is equals to what? Wavelength in medium 1 divided by what? Wavelength in medium what? 2. We can also say that it is equals to what? The speed in what? Deep water divided by what? Speed in shallow water. So all these things are related to the refractive index of glass. And mind you, this refractive index of glass is always constant and is equals to 1.5. So if you know that n is equals to 1.5, you can as well solve for anything like angle of incidence or angle of refraction. Okay, because it's equals to I over what? Sine what? R. Then another thing, you may be asked to get this angle of deviation here. How can we solve for this angle of deviation? We can solve for this angle of deviation if you know that angle of incidence I is equals to angle of refraction R plus angle of deviation. Vertically opposite angle are equal. So that means I is equals to R plus what? D. So if I can ask to find this angle of deviation, my deviation D is equals to I minus what? R. So my angle of deviation becomes the angle of incidence minus the angle of what? Refraction. So let us look at this problem on the board. A beam of light is incident from air to water at an angle of 30 degrees. Find the angle of refraction if the refractive index is 4/3. Calculate also the angle of deviation. So for us to be able to state this, we have to state the parameters. Okay, solution, since it is incident, that means my angle of incidence is 30. So I is equals to 30 what? Degrees. We are looking for R, so R is unknown. The angle of the refractive index N is given as 4/3, of which we can still divide it. We can change it to decimal by saying 4 divided by 3 equals 1.33. Okay, so we're going to use the Snell's law formula, which states that what? N is equals to sine I over sine what? R. Now we are given the refractive index N as 1.33, and we have I, which is 30. They ask to find the angle of refraction, which is R. Using our formula, so we have 1.33 is equals to sine 30, which is my I, divided by what? Sine R. Since I'm looking for this, I will say this is over 1 cross multiply. Sine R is equals to sine 30 over 1.33. Okay, so let's find out what is sine 30. Sine 30 is equals to 0.5. I will say 0.5 over 1.33. So let me divide. 0.5 divided by 1.33. What do I have? I have sine R is equals to 0.3759. Okay, since I'm looking for my R, I will say R is equals to sine inverse of 0.3759. What do I have? Shift sign, answer. I'm going to have R to be 22.08 degrees. That is my angle of what? Refraction. And the deviation D is equals to I minus what? R. Although my I was given as what? 30. I'll now subtract it from 22.08. If I subtract, I will say 30 minus 22.08. What do I have? I will have 7.92. 7.92 degrees. That is my what? Angle of what? Deviation. So my angle of refraction is 22.08 degrees, and my angle of deviation is 7.92 degrees. I hope you understand this video. So this is how we can use the refractive index to solve for the angle of deviation and the angle of refraction. Please, I'm going to put up an assignment on my page so that you can solve and drop the answer in the comment section. And if you have not subscribed to my channel, please do well to subscribe for more videos. Stay tuned. Bye.